Hey guys, in this video we are going to talk about transforming quadratic graphs. And to do that, we first have to learn about the y-stretch factor. So we need to start with what is called the base graph, y equal to x squared, which is the simplest form of a quadratic relationship, and it is also the simplest equation of a quadratics. So let's do the base graph first, and this is something that you must be able to do fluently. So make sure you learn how to do this without even too much thought. So with the base graph, x is given. I've just taken these numbers, -2, 2, 2, and then the base graph is y equals x squared. So what we're doing here is substituting the -2. We are squaring that. So we get a 4. Substituting this, -1, 1, 0 to the power of 2 is that. 1 squared is 1, and 2 squared is 4. So let's put all these points on the graph grid that we have. The first is -2 and 4. So -2 and 4. And -1 and 1. 0, 0, 1, 1, and 2, 4. Let me fix that. 2, 4. Okay, so this kind of looks too small. So what I'm going to do is I'm going to plot 2 extra points just to make it look nice. So if I go to -3 and if I square that, -3 squared is +9. And +3 squared is +9. So what I have is a parabola that looks like this. All right, so this is what you would call a base graph, y equal to x squared. So what happens if I have to plot y equals 2x squared? Y equals 2x squared. So what will be the difference between the column here, this column, y equals x squared column, y equals 2x squared column? We have the x squared values here, 4, 1, 0, 1, and 4. So if I multiply the first column here by a 2, I will get the second column, right? So simply double the values of these guys. So either you can put that into your calculator like this, 2, -2 to the power of 2, you will get 8. Notice that it's 4 times 2, 8. Or you can just simply multiply the 1 here by the 2. So 1 times 2 is 2, 0 times 2 is a 0, 1 times 2 is a 2, 4 times 2 is a 8. So either you apply the formula like you see in the first entry, or you can say, all right, x squared values are given here, and you can simply have to double it. So what will it look like on the graph? So -2 is 8. So -2 is 8, and -1 is a 2, and 1 is a 2, -2 is a 8. So I cannot do the third point here, that is the 9 and 9, because 9 times 2 is 18. It goes outside the graph, so I'm not able to get that. But this is what happens. So you notice here, when I join these points, I get a parabola that is skinnier than before. So what's really happened here is that the second graph, 2x squared, here, this one, it is stretched by a factor of 2. So that is the 2 that we have here. So basically, take the base graph, take all the y values, and you're doubling them. You're keeping the x values the same. So the 1 is the same here. See the original value 1 here, y value, now it's become 2. The original y value of 4 has become 8. If we had space, we will double this as well. The third one, 9, will become 18. You're repeating it on the other side as well. So the whole graph has become twice as tall, but we don't use the word tall in mathematics. We will say it is stretched by a factor of 2. In fact, it is stretched vertically. It is stretched vertically by a factor of 2, vertically indicating that it is the y-axis. Now, what happens to something like y equals half x? Remember, half is the same thing as 0.5. So you can put this into your calculator and you can go 0.5 and then negative 2, that is coming from the x value here. And if you square it, what you will get is a 2. All right, or what I can do is I can take these base values, the y values, and I can make each of them half. So example, half of 1 is a half of 0 is 0, half of, sorry, I made a mistake here. So no, I'm good, I'm good. So half of 1, and then half of 1 again is 0.5, and half of 4 is 2 again. So let's plot these blue ones. So notice here, for x equals negative 2, the y value is negative 2 is 2. So I put here, compare it to the base graph, the original value at that point was 4. Now it has become half as much. 4 has become a 2. In the same way, you look at this here. I'm going to kind of blow it up a little bit so the graph looks a little easy for you. So here, you notice that the y value in the base graph is a 1. Now it becomes a half. The origin does not change. It is still 0, 0. The y value on the right side, that is a 1, that has become a half. The y value here is a 4, 2, 4. Now it becomes 2, 2. And lastly, the y value here is 3, 9, and now it becomes 3, 4.3, a half of it, 3, 4.5. So count that properly, and that is 4.5. And because of symmetry, you can go straight to the other side, and you have that. And you have now a graph that's kind of looking fatter. Okay. Now, some textbooks, they call this compression. But I don't like to use that word compression because it causes a lot of confusion later on. So I'm going to keep the language a little simple. So if you look at the third graph that we have here, that comes from this equation. So here we can say it is stretched vertically by factor of half, or I can always say stretch vertically by half. It also means the same thing, by a factor of half. All right, what about the last one? So let's say we have y equals a negative number that is multiplying the x squared here. So we will follow the same idea as before. We can do it this way. We can substitute the x value of negative 2 here and square that. What I will get is a negative 4. You can punch that into your calculator to confirm it for yourself. Or what I can do is I have these x values. And what I'm doing is I'm simply multiplying the the y values, I apologize. The y values, I'm going to multiply the y values, which is the same thing as the x squared, by a negative 2. So if I do that, the y value here is a 1 multiplied by negative 2. I get that, multiply the 0, it remains the same. You get a negative 2 and you get a I'm sorry, I made a mistake here. This is 8. This is -8, and then you will get a -8 again. Okay, you can verify this into a calculator. For example, if you do -2, put the 2 there, that is squared. So you have -2 multiplied by 4, that is -8. And that's how I can get these values as well. So here, when I go back to this graph, what I have here is -1, -2, I get a -8. Okay, so I get a -8. And -1, I get a -2. Okay, so right about there. And 0 is the same thing as 0, 0 comma 0. +1, I get a 2. +2, I get a -8. So I join these. I still have a parabola, but instead of opening up, it opens down. Instead of opening up, it opens down. So how do we make a conclusion from all this? So in general, if we have y equals ax squared, where a is called the y stretch factor, okay, if the a values are bigger than 1, something like say 2 that we saw, we get a vertical stretch. The graph becomes stretched in the positive direction. Okay, so we have a vertical stretch. Okay, so if the a value is less than 1, which means the a values are negative, we still get a vertical stretch, but now a is negative. So you have a vertical stretch, and you have a reflection about x-axis. That is, instead of opening up, here, not only it's stretching, but it's stretching downwards. It is a reflection. Okay, numbers bigger than 0, numbers smaller than 0. Okay, but what about numbers between 0 and 1? So if you have numbers between 0 and 1, instead of having a stretch, it looks compressed, like this blue graph looks compressed compared to the black one here. So the blue is compressed. So it is compressed. But like I said before, we never use that word compressed in our course. We'll always say stretched by a factor of a half, stretched by a factor of a third. So we will still use the word stretched when we write our answers, but this is for making some good notes, okay? What about if it is between 0 and -1? It will not just be compressed, it will also be reflected because it is a negative number. Okay, so it'll be reflected about the x-axis. Okay, I know this concept is new, but it is a very simple concept, really. Just watch the videos a few times, make good notes, and it should become clear for you very soon. See you in the next video.